Welcome to lesson 9.3, graphing quadratic functions. So we've already looked at the idea of quadratic equations and simplifying our radicals. Now we're moving into how we graph quadratic functions. So the first thing to keep in mind is the standard form for a quadratic function or quadratic equation is y equals ax squared plus bx plus c. So a, b, and c are all going to be possibly different numbers, but they are our coefficients for a and b and a constant for c. Now, if we move on from our standard form, the next term we need to be cognizant of or aware of is a parabola. And a parabola is the figure that we get when we graph a quadratic function. It makes a big U shape, which opens upward if A in our formula is positive, and if A is negative, it's an upside down U. So it's opening down if A is negative. So your graph, a parabola, looks like a big U or an upside down U. Then another term we need to know is axis of symmetry. So the axis of symmetry is a vertical line that cuts the parabola in half. And the reason the axis of symmetry is so important is by finding the axis of symmetry, we can find the vertex. So our equation for axis of symmetry is x equals opposite of b divided by 2 times a. So opposite of b over 2a is how we find axis of symmetry. And then we have the vertex. And the vertex is the ordered pair that is on the axis of symmetry. So it's in the middle of the parabola. And this point is either the maximum or minimum of the function. So it's either the lowest point if the parabola is opening up, or the highest point if the parabola is opening down. So we have our standard form for the equation, a parabola, which is the figure that's graphed, axis of symmetry, which is the vertical line that cuts the parabola in half, and the vertex, which is the ordered pair point that lies on the axis of symmetry, and it's where our parabola either has its maximum or minimum point. So let's practice a few of these to make sense of it. So first off, example 1 says use the function y equals x squared minus 4x plus 4 to answer the following questions. So right away, it's just asking, does the parabola open up or down? So what we care about is a. So what's in front of the x squared? And in this case, it would just be the number 1, because there is nothing in front of x squared, so it would be 1x squared. So because a is positive, it's not a negative in front, our parabola opens up. Anytime a is positive, it opens up. If it was negative, it would open down. For b, what is the equation for the axis of symmetry? So axis of symmetry equations right here, x equals opposite of b over 2a. So if we look at our original equation, and our standard form is ax squared plus bx plus c. A, we already know, is in front of the x squared, which is 1. B is in front of the x, which would be a negative 4, because it's minus 4x. And just so you know, then c, if we needed it, would be the final digit here, which is 4. So in this case, b is a negative 4, a is 1. So when we put it into x equals opposite of b over 2a, it would be a positive 4 over 2 times 1. So 4 over 2, which simplifies to 2. So x equals 2. So our axis of symmetry is x equals 2. which also means our vertex's x-coordinate is 2. So whatever you get for your axis of symmetry is always going to be the x value of your vertex. So then how do we find our vertex? We're going to use the value from the axis of symmetry, and we're going to put it in to the original equation. So in y equals x squared minus 4x plus 4, we're going to put a 2 in for x because that was our axis of symmetry. So instead of x squared, it'd become 2 squared minus 4 times 2 plus 4. 2 squared is 4, minus 8 plus 4, which means y equals 0. So we already knew the x was 2, y is 0, so our vertex is at the ordered pair 2, 0. So now to graph it, we want to make a table of points. And you always want to use at least 5 points, 2 on each side of the vertex. So in this case, the vertex would go here in the middle of my table, x value 2, y value 0. Then the next numbers that I'm going to put in for x are going to be 2 to the left of that, so 1 and 0, and 2 to the right, which would be 3 and 4. Now to get my y values, I'm doing the same thing that I did here with the 2 for the vertex, and I'll be putting these numbers in for x in that original equation. So if we do the top one here, it would be 0 squared minus 4 times 0 plus 4. Well, 0 squared is 0. Minus 4 times 0 is 0 plus 4 is simply 4. So we'd have the point 0, 4. If we put a 1 in for x into this equation, we get a 1 for y, so that point is 1, 1. Then when we put in the 3, we would have x squared minus 4x plus 4, so 3 squared minus 4 times 3 plus 4, giving us 1. And when we put in a 4, we end up with y equals 4. So then the last thing we do is we graph our parabola using these 5 points. So we have our vertex over 2 up 0, then over 1 up 1, over 3 up 1, over 4 up 4, and over 0 up 4. And then you can see if we draw in our curves, that gives us a U shape with the vertex at 2, 0. So another example, example 2, use the function y equals the opposite of x squared plus 2x minus 1. So first, does it open down or up? What's in front of the x squared is a negative 1, so that means a is a negative 1. If a is negative, it opens down. The equation for the axis of symmetry, again, every time we're using opposite of b over 2a. So our axis of symmetry, if we look at our equation here, b is a negative 8, so opposite of b would be a positive 8, over 2 times a, which is a negative, oh, sorry, I went down too far. Skipping back, this one. What is the equation for the axis of symmetry? On this equation still, b is 2, a is negative 1. So opposite of b would be a negative 2 on bottom, 2 times negative 1. Negative 2 over negative 2 is 1. So for axis of symmetry, x equals 1. Now again, we're going to use that to find the vertex. So we're going to use x equal 1 and put it into the original equation to get y. So when we do that, we'd have 1 squared, and the negative would be out in front of that, plus 2 times 1 minus 1. So we'd end up with a negative 1 plus 2 minus 1, meaning y would equal 0. So our vertex is at the point 1, 0. Now, because it's opening down, our vertex is our maximum point or the highest point. But again, when we do our graphing, we can just start with the vertex, put that in the middle of your table, And then to figure out your other x values, if our vertex is 1, I'm going to put in a 0 and -1 and a 2 and a 3. So then when we do that, plugging each one of these x's into the original equation, I'm not going to show all the work, but you would end up with these y values. So we'd have the point -1, -4, 0, -1, 1, 0, 2, 1, and 3, -4. So when we look at our graph, we would have over 0 down 1, over -1 down to -4, over 1 down 0, over 2, and that should be a -1 right here. So that should be 2, -1. And then 3, -4. So we get our upside down U shape. Now, example 3. We have a number out in front that's not a 1 or -1. Doesn't matter. Whatever number is in front of x squared is a. So a is a -2, meaning our parabola opens down. For part B, what is the equation for the axis of symmetry? Opposite of b over 2a. So if b is a -8, opposite that would be 8 over 2 times the -2. So that'd be 8 over -4, which gives us -2. Now we're going to put in -2 for x in the original equation to get the y value of our vertex. So when we put the -2 in for x, we'd end up with -2 times the -2 squared, which gives us -8. -8 times -2, which is a positive 16, minus 6. So y would equal 2. So our vertex is at -2, 2. So that goes in the middle of our table. Then we can use our other x values. So if it's at a -2, I use a -3 and a -4, a -1 and a 0. Put each of those into the original equation for x to get your y values. Once you have your values, we can graph our parabola. So it'd be left 4, down 6, left 3, down 0, left 2, up 2, left 1, down 0, over 0, down 6. And then you can draw in your curves to connect your points, and you should get this parabola opening downward. Then we go to our last example, example 4, which says use the function y equals x squared minus 7x plus 12. So in this case, a is a positive 1, whatever's in front of x squared, so our parabola opens up. The axis of symmetry would be the opposite of b over 2 times a. So if b is a -7, it would be a positive 7 over 2 times 1. So 7 divided by 2 is 3.5 or 3.5. So now, instead of a whole number for x, we have a decimal. Doesn't matter. We're still going to put 3.5 into this original equation for x to find our y value. So in this case, when we do that, 3.5 squared minus 7 times 3.5 plus 12 gives us a -1/4 or a -0.25. So my vertex is at 3.5, -0.25 or -1/4. Now, because x is a decimal, I'm going to use whole numbers for the rest of my values still. So I'm going to go left to the 3 and to the 2 of our vertex, and then right to 4 and 5. So then we're going to put in a 2, a 3, a 4, and a 5 into the original equation for x. Solve that to get your y values. So we'd end up with the points 2, 2, 3, 0, 3.5, -1/4, 4, 0, 5, 2. So then we should end up, once we plot our points, with a curve opening up for our parabola here. So the key to this lesson comes back to really understanding the standard form, how we find the axis of symmetry, which allows us then to find our vertex, and then plugging in 4 other points for x to get your y values.